Hello there. Welcome to the Sleepy Science Channel. Tonight, we are going to drift away from the surface of the world. We are going to leave behind the tall buildings, the busy streets, and the bright lights that define our waking hours. We are going to travel inward, into the quiet, hidden heart of reality. Tonight, we speak of the quantum world. But do not worry. There are no equations to solve here. There are no tests to take. We are simply going to wander through the strange and beautiful garden of the subatomic universe. We are going to look at the fabric of existence itself, inspecting the threads that weave together to create you, to create this room, and to create the stars. So before we begin, take a moment to settle in. Let your body sink into the mattress. Feel the weight of your shoulders releasing their tension. Feel the back of your head resting heavily on the pillow. Close your eyes. Let the darkness behind your eyelids become a vast, open space. A space where we can float. A space where the rules of the everyday world no longer apply. Everything you see around you, everything you touch feels solid. It feels continuous. The air feels like a smooth ocean. The table feels like a hard, unbroken surface. But this is an illusion. It is a beautiful, convincing mask worn by the universe. If we were to peel back this mask, if we were to shrink down, smaller than a dust mite, smaller than a bacteria, smaller than a virus, we would find that the smoothness is a lie. The first truth of the quantum world is that everything is granular. Imagine a beach seen from high up in an airplane. It looks like a sheet of gold. But as you descend, as you land and walk upon it, you see that the sheet is made of billions of tiny, separate grains of sand. Our reality is exactly like that beach. Energy is not a continuous flow like water. It is a rain of tiny packets. These packets are called quanta. Light is not a smooth wave, but a stream of tiny particles called photons. The world is pixelated. And tonight, we are going to zoom in on those pixels. Let us start with the atoms that make up your body. Right now, as you lie there, you are a galaxy of atoms. But what does an atom look like? We often picture it like a tiny solar system with a nucleus in the middle and electrons orbiting around it like little planets. But that picture is too crowded. It is too busy. The reality is far more spacious. The reality is mostly silence. Here is a fact to hold in your mind as you drift. An atom is almost entirely empty space. To understand just how empty, we must change our scale. Imagine that the nucleus of an atom, the heavy, dense center where almost all the mass lives, is the size of a marble. A single small glass marble. Now, imagine we place that marble in the absolute center of a gigantic football stadium. Where are the electrons? Are they in the front row? No. Are they in the parking lot? Maybe. If the nucleus is that marble in the center of the field, the electrons are tiny, invisible specks of dust whirling around the very top seats of the stadium, hundreds of meters away. And what is in between the marble and the dust? Nothing. Absolutely nothing. Just vast, empty, silent void. Every atom in your body is 99.9999999% empty space. You are a cathedral of emptiness. You are a ghost made of a few tiny specks of matter held together by invisible fields of force. If we could somehow pinch all the empty space out of you, if we could squeeze the electrons down until they touched the nucleus, your entire body, all your weight, all your complexity would fit inside a speck of dust invisible to the naked eye. If we did this to every human being on Earth, all 8 billion of us, every city, every crowd, the entire human race would fit inside the volume of a single sugar cube. That sugar cube would weigh billions of tons, but it would be all that we actually are in terms of solid matter. The rest is just illusion. The rest is just geometry and force fields keeping things apart. Think about that spaciousness. You are not a dense, heavy object. You are airy. You are open. You are mostly made of the same nothingness that fills the space between the stars. So why do you feel solid? Why don't you fall through the bed right now? Why does the floor hold up the chair? If atoms are mostly empty space, they should pass right through each other, like two clouds of smoke merging. The answer lies in the forces. The electrons that whirl around the outside of those atoms carry a negative electrical charge. And as you know, like charges repel. When the atoms of your body descend toward the atoms of the bed sheets, those electron clouds meet. They push against each other with incredible ferocity. They refuse to occupy the same space. This leads us to a strange realization. You have never actually touched anything in your entire life. When you think you are touching the wall or holding a stone or brushing a loved one's hand, there is no physical contact. The atoms never collide. They hover. The electrons in your skin push against the electrons in the object, creating a tiny microscopic gap. You are floating on a cushion of electromagnetic force, hovering a millionth of a centimeter above everything you encounter. You are always slightly separate. You are always held in a gentle suspension, carried by the invisible forces of the universe. Let this feeling of floating wash over you. You are not being crushed by gravity. You are being supported by the electromagnetic hum of the universe. And where did these atoms come from? This is the story of your origins. The hydrogen in the water of your cells, the simplest atom, just one proton and one electron, is ancient. It is the oldest thing in existence. Those hydrogen atoms were born in the first 3 minutes of the universe, just after the Big Bang. They have traveled for 13.8 billion years. They have floated through the dark ages of the cosmos before the first stars ignited. They have drifted through nebulae and void to end up here, tonight, inside you. But you are not just hydrogen. You are carbon, oxygen, nitrogen, iron. These are heavier, more complex atoms. And the universe did not begin with them. They had to be made. They had to be forged. Every atom of carbon in your muscles, every atom of calcium in your bones, every atom of iron in your blood was created inside the crushing, fiery heart of a giant star. Long before the Earth existed, massive stars lived and burned. In their cores, they took the simple hydrogen and fused it, squeezing it together to make heavier elements. They were cosmic alchemy factories, turning the dust of the Big Bang into the building blocks of life. And when those stars reached the end of their lives, they did not just fade away, they exploded. They went supernova. They tore themselves apart, scattering their insides across the galaxy. They threw the carbon and the iron and the gold out into the darkness. That dust drifted for eons. It swirled and clumped together. It formed a new star, our sun. It formed planets. It formed the Earth. And eventually, it formed you. So when we say, "You are made of stardust," it is not poetry. It is a literal scientific fact. The iron that anchors your blood to this planet was once in the center of a dying star. You are the afterlife of a star. You are the universe organizing itself into a form that can breathe and think and sleep. And these atoms are yours only for a moment. You are borrowing them. Every time you breathe out, you release sextillions of atoms back into the world. Every time you breathe in, you take in atoms that were once part of something else. Mathematical probability tells us that with every breath you take, you inhale at least one atom that was once in the lungs of Albert Einstein, or Isaac Newton, or a dinosaur wandering through a Jurassic jungle, or the first person to ever look up at the moon. We are all connected in this great, slow cycle of breath. The atmosphere is a vast library of history, and we are constantly reading it, taking it into our bodies, and writing our own chapter before exhaling it back out. Now, let us go deeper. Let us look at the light. Imagine a beam of sunlight coming through your window. It looks warm and constant, but we know now that it is made of particles, photons. A photon is a strange little thing. It has no mass, it weighs nothing. Because it is weightless, it never slows down. From the moment it is born, it travels at the speed of light. It can never stop, and it can never accelerate. It just is motion. But here is the most mind-bending fact about light. Light does not experience time. We know from Einstein's relativity that the faster you move, the slower time passes for you. If you could travel at the speed of light, time would stop completely. This means that for a photon, there is no journey. We see the light take 8 minutes to travel from the sun to the Earth. We wait for it. But for the photon itself, the moment it leaves the surface of the sun and the moment it hits your eye are the exact same moment. It crosses 93 million miles of space in literally 0 time. From the perspective of light, the universe has no size. Everything is touching. The birth of the light and its death are simultaneous. Think about the journey that light took to reach you. The photon began in the core of the sun. It was born from the violent collision of atoms. But the core of the sun is so dense, so crowded, that the photon could not travel in a straight line. It crashed into an atom immediately. It bounced. It was absorbed and re-emitted. It moved a fraction of a millimeter before crashing again. It is a drunkard's walk, a random, chaotic struggle to escape. It can take a photon 100,000 years just to fight its way from the center of the sun to the surface. 100,000 years of bouncing in the dark, fiery crush of the star. So the sunlight that hit your face today was not born this morning. It was born when humans were still living in caves. It was born before the pyramids were built. It has been struggling to reach you for millennia. And once it finally broke free from the surface of the sun, it leaped across the emptiness of space in 8 minutes of our time and 0 seconds of its own time just to warm your skin. Every ray of light is an ancient messenger. Every photon is a traveler from the deep past, arriving instantaneously in your present. And yet, this particle, this tiny traveler from the sun, holds a secret that challenges everything we think we know about the world. We call it a photon, a particle, a distinct thing like a marble or a grain of sand. But if we look closer, the distinction begins to blur. The particle dissolves into something softer, something more fluid. This brings us to the great duality. The universe is not made of hard, separate objects. It is made of ripples. Imagine you were standing at the edge of a calm, dark lake at night. You throw a stone into the water. You see the ripples spread out in perfect circles, moving away from the splash. Now imagine you throw two stones at the same time. The ripples from the first stone meet the ripples from the second. They dance together. Where two crests meet, the water rises higher. Where a crest meets a trough, the water goes flat. They pass through each other, creating a complex, beautiful pattern of interference. Light behaves exactly like this water. It flows, it bends around corners, it spreads out. But here is the strange part. It is not just light. You, too, are a ripple. In the early 20th century, a French prince named Louis de Broglie made a radical suggestion. He proposed that if light, which we thought was a wave, can act like a particle, then matter, which we think of as particles, must act like a wave. He suggested that electrons, protons, and even whole atoms have a wavelength. And he was right. The electrons spinning inside your body right now are not solid little balls. They are not planets orbiting a sun. That is a picture we draw for children. In reality, an electron is a vibration. It is a standing wave, like the note plucked on a guitar string. It does not exist in one specific place. It exists as a cloud of probability. It is smeared out around the nucleus of the atom, existing everywhere at once in a ghostly haze. This means that the edges of your body are not as sharp as they look. Because you are made of atoms, and atoms are made of waves, you technically do not have a hard boundary. The wave function of the atoms in your fingertip does not stop at your skin. It trails off, getting fainter and fainter, extending out into the air, out into the room, and mathematically out to the ends of the universe. There is a tiny, infinitesimal chance, so small it's practically zero, but not exactly zero, that an electron from your hand could be found on the moon right now. You are not contained. You are a localized vibration in a field that stretches everywhere. You are a song being played by the universe, and your melody extends further than you can see. Now let us drift toward the greatest mystery in all of quantum mechanics. It is a story that sounds like a dream, but it happens in laboratories every day. It is the story of the double slit. Imagine a wall with two narrow vertical slits cut into it, like two tall windows. Behind this wall is a screen. If we were to fire tennis balls at this wall, some would bounce off and some would pass through the slits. On the screen behind, we would see two piles of balls. One pile behind the left slit, one pile behind the right slit. This is how the world we know behaves. Things go where you send them. But now, imagine we shrink down again. Instead of tennis balls, we fire electrons. We fire them one by one. Click, click, click. We let them fly through the darkness toward the two slits. You would expect to see two piles of electrons on the screen, but that is not what happens. Instead of two bands, we see many bands. We see a series of stripes, dark light, spread out across the entire screen. This is an interference pattern. It is the same pattern we saw with the ripples in the lake. This tells us something impossible. It tells us that the single electron did not go through the left slit, it did not go through the right slit, it went through both slits at the same time. In the solitude of the dark, when no one was watching, the electron became a wave. It split itself in two, passed through both windows, interacted with itself, and then touched the screen. It explored all possible paths simultaneously. It was a ghost of pure potential. But the mystery deepens. This is where the universe begins to feel like it is aware of us. Scientists, puzzled by this, decided to be clever. They said, let us watch the electron. Let us put a tiny sensor, a camera, right next to the slits to see which one it actually goes through. So they set up the detector, they turned it on, they fired the electron. And the moment they looked, the magic stopped. The electron did not pass through both slits. It didn't act like a wave. It snapped back into being a solid little particle. It went through just one slit. The beautiful pattern of many stripes on the screen disappeared, replaced by two boring piles. Just by watching, we changed the reality. This is known as the observer effect. It suggests that the universe plays by two different sets of rules. When we are not looking, the world is fluid, dreamy, and full of infinite possibilities. Things exist in a superposition. They are here and there, up and down, all at once. But the moment we look, the moment we measure, the moment we interact, the world freezes. It decides. It collapses into a single solid reality. It is as if reality is a shy performer that stops dancing the moment it realizes it has an audience. Think about the way this means for the room you are in. Behind you, where your eyes are not looking, is the world solid, or is it a shimmering soup of probability? Does the chair in the corner exist in a definite state, or is it only when you turn your head that it snaps into position? Of course, the air molecules are constantly bumping into the chair, observing it, keeping it real. The universe is constantly observing itself, knitting itself together through interaction. But deep down, at the bottom of everything, the solid world is just a facade. Underneath, there is only a vast ocean of maybe. Let that word float in your mind. Maybe. The universe is not made of hard facts. It is made of possibilities waiting to happen. And this blurriness applies to more than just position. It applies to time itself. Let us talk about the cat. You have likely heard of Schrödinger's cat. It is a famous riddle, a paradox designed to show how strange this quantum world is. Erwin Schrödinger asked us to imagine a box. It is sealed. You cannot see inside. Inside the box is a cat. Also inside the box is a tiny, unstable atom and a machine that will release a sleeping gas if the atom decays. Quantum mechanics says that until you measure the atom, it has not decayed and it has decayed, both at the same time. It is in a superposition. Therefore, the machine has triggered and not triggered. Therefore, the cat is asleep and awake. Both realities exist simultaneously inside the box. The cat is walking around and the cat is lying still. Two separate histories are happening at once in the dark. Only when you open the lid do you force nature to choose. The two ghosts merge into one reality. The universe decides. This sounds impossible to our human minds. We live in a world of either or. Either it is raining or it is not. Either you are asleep or you are awake. But the particles that make you up live in a world of and. They live in a world where contradictory things are true at the same time. Some physicists believe this doesn't just happen in boxes. They believe in the many worlds interpretation. They suggest that the universe never actually chooses. They say that when you open the box, reality splits. In one universe, you open the box and the cat is awake. In another, completely separate universe, a version of you opens the box and the cat is asleep. This would mean that with every quantum event, every time an electron moves, every time a photon hits a leaf, the universe branches. It creates a new copy of itself. Imagine the implications of this. It would mean there are infinite versions of you. There is a universe where you didn't make that mistake. There is a universe where you took the other path. There is a universe where you are already asleep, dreaming deeply. And there is this universe, right here, where you are listening to these words, safe and warm. All of them are real. All of them are happening right now, stacked on top of each other, like pages in an infinite book, but we can only read one page at a time. Feel the vastness of that idea. You are part of a multiverse, a sprawling, endless tree of life where every possibility is explored. You are never truly trapped, because in the quantum realm, every road is taken. But if there are infinite versions of reality, and if particles are just ghostly clouds of probability, then what does that mean for the barriers we see in our world? We are taught that a wall is a wall. We are taught that solid objects cannot pass through one another. If you throw a ball at a brick wall, it bounces back. It has to. It does not have the energy to break through, so it stops. In the quantum world, however, impossible is a word that does not exist. There is only unlikely. This brings us to the phenomenon of quantum tunneling. It is perhaps the most magical of all quantum behaviors because it allows particles to do exactly what ghosts do in stories: walk through walls. Imagine a roller coaster. It is sitting at the bottom of a valley, and there is a tall hill ahead. If the coaster does not have enough speed, it will go halfway up the hill, stop, and roll back down. It cannot cross to the other side. Physics forbids it. But an electron is not a roller coaster. An electron is a wave, and waves do not have hard edges. They have tails that stretch out. When an electron approaches a barrier, like an electric field or an insulating material, most of its wave bounces back. But a tiny, tiny piece of that wave extends through the barrier to the other side. And because the electron can be anywhere its wave is, there is a small chance that it simply vanishes from one side of the hill and instantly reappears on the other side. It does not climb the hill, it does not drill a hole through it, it simply teleports through the obstacle as if it were not there. This is not just a rare curiosity. It is happening all around you, right now. It is happening inside the device you are using to listen to this. The flash memory in your phone or computer works by trapping electrons in a secure chamber. The only way we can erase that memory or write new data is by forcing those electrons to tunnel through a solid barrier, slipping through the walls of their prison to change the state of the chip. Every digital memory you have is preserved by quantum magic. But there is a far more important example of tunneling. Without it, the night sky would be dark, the moon would be invisible, and the Earth would be a frozen ball of ice. Tunneling is the reason the sun shines. Deep in the core of our star, the pressure is immense. Hydrogen atoms are being crushed together. The goal of the star is to fuse these atoms, to smash two protons together to create helium and release energy. That energy is sunlight. But there is a problem. Protons are positively charged. They are like powerful magnets with the same polarity. As they get closer, they repel each other with tremendous force. This is the Coulomb barrier. Even in the crushing heat of the sun's core, the protons do not actually have enough speed to overcome this repulsion. They should bounce off each other forever. By all the rules of classical physics, nuclear fusion should be impossible in our sun. It is not hot enough. But the protons are quantum particles. They are fuzzy. And because of tunneling, occasionally, very, very rarely, a proton defies the odds. It borrows energy from the vacuum, slips through the magnetic shield of its neighbor, and fuses. It happens to a single proton only once in billions of years, but because the sun contains so many protons, it happens enough times every second to ignite the star. The warmth you feel on your skin in the summer, the light that feeds the plants, the energy that drives the winds, it is all the result of particles walking through walls. We exist because the fundamental particles of matter can cheat the rules of resistance. Let that thought warm you. The universe is lenient. It allows for miracles when the barriers seem too high. Now, let us expand our view. We have looked at the very small, but what happens when we look at the very far? We tend to think that for two things to affect each other, they must be touching or at least close by. If I want to move a book, I must push it. If I want to speak to you, sound waves must travel from me to you. But the quantum world mocks the idea of distance. It mocks the idea of separation. This is the mystery of entanglement. Albert Einstein called it spooky action at a distance. It troubled him deeply because it suggested that space itself is an illusion. Here's how it works. Sometimes two particles are created together. Maybe a crystal is struck by a laser and splits a photon into two. These two new particles are born entangled. They share a destiny. They are mathematically the same object, just split in two. We can take one of these particles and keep it here in a laboratory on Earth. We can take the other one and put it on a rocket ship. We can send it to the moon or to Mars or to the other side of the galaxy millions of light years away. Now, we look at the particle on Earth. Let's say we measure its spin, a quantum property that is like a coin toss. It can be spinning up or down. Before we look, it is doing both. But the moment we look, it decides. Let's say it turns out to be up. Here is the spooky part. The exact instant we measure the particle on Earth, its partner on the other side of the galaxy will instantly snap into the opposite state. If the Earth particle is up, the galaxy particle becomes down. It happens instantaneously, faster than the speed of light. There is no signal sent between them. There's no invisible wire. The universe doesn't wait for a message to travel across the void. The change just happens. It is as if the two particles know what the other is doing across any distance without any time passing. It implies that, on some deep hidden level, they are still touching. It implies that the millions of miles of space between them are not real boundaries. Think about the beginning of time. Think about the Big Bang. 13.8 billion years ago, all the matter in the universe, every drop of water, every rock, every star, every atom in your body was crushed into a single point smaller than an atom. Everything was touching. Everything was entangled. Then the universe exploded outward. The pieces flew apart to form the galaxies. But if they were entangled then, are they still entangled now? Some physicists believe that everything in the universe is connected to everything else by these invisible quantum threads. The atoms in your hand may be subtly linked to atoms in a star burning on the edge of the observable cosmos. We are not isolated fragments drifting in the dark. We are part of a single vast breathing web. The separation between you and the world, between you and the stars, is just a trick of perspective. Under the surface, we are all one thing. And this web is not just made of matter. It is made of the space itself. We used to think of space as a stage, an empty black box where the drama of the universe happens. We thought that if you took away all the stars and planets, you would be left with a boring static nothingness. But quantum mechanics tells us that nothing is actually something. In fact, nothing is incredibly heavy. This is the concept of the quantum vacuum. If you look at empty space with a microscope powerful enough, you see that it is not smooth and it is not quiet. It is boiling. It is a frothing foam of energy. Because of the uncertainty principle, nature forbids absolute zero energy. So in the deepest void, particles are constantly popping into existence. They appear out of nowhere, a particle and its mirror image antiparticle. They borrow energy from the vacuum itself, snap into existence, live for a billionth of a nanosecond, and then crash back together, annihilating each other and returning their energy to the void. It's like the surface of the ocean. From a distance, it looks flat, but up close, there's chop, foam, and bubbles rising and bursting. Right now, in the empty space between your eyes and your eyelids, in the empty space between the atoms of your brain, this dance is happening. Virtual particles are flickering in and out of reality like fireflies. You are filled with a sparkling, effervescent potential. The vacuum is alive. This zero-point energy means that there is no such thing as true silence in the universe. Even in the coldest, darkest grave of space, there is a hum. There is a vibration. The fabric of reality is constantly shivering with the effort of existing. And this shivering might be what gives things their weight. For a long time, we didn't know why things had mass. Why is a rock heavy? Why is a photon light? Then we found the Higgs field. Imagine the universe is filled with a thick, invisible syrup. This is the Higgs field. It is everywhere. It permeates your room, the Earth, the galaxy. When particles move through this field, they have to push against it. Some particles, like photons, slip through the syrup without touching it. They stay weightless and fly at the speed of light. But other particles, like electrons and quarks, get stuck in the syrup. They experience drag. They slow down. They get heavy. The mass of your body, the feeling of weight you have right now as you press into the mattress, is the result of your atoms interacting with this invisible cosmic ocean. You are interacting with the Higgs field right now. It is holding you. It is giving you substance. Without it, your atoms would fly apart at the speed of light and you would dissolve into radiation. You are anchored to this reality by the invisible sea that fills the room. And just as there is a sea that gives us weight, there is a shadow side to the matter we can touch. We tend to think that the stuff we see, the protons, electrons, and neutrons, is all there is. But the equations of the quantum world reveal a startling symmetry. Nature loves reflections. In the early 20th century, a physicist named Paul Dirac was looking at the math of the electron, and he realized that for the equations to work, there had to be something else. There had to be an opposite. He discovered antimatter. For every particle that makes up your body, there is a mirror twin somewhere in the universe. For the electron, which has a negative charge, there is the positron, a particle with the exact same mass but a positive charge. For the proton, there is the antiproton. This is not science fiction. We create these particles in labs every day. They rain down on the Earth from cosmic rays constantly. But they are dangerous lovers. If a particle of matter ever meets its antimatter twin, they do not bounce off each other, they do not merge, they annihilate. They completely destroy each other, vanishing in a flash of pure 100% energy. It is the most efficient release of power in the universe. A single gram of antimatter, no bigger than a paperclip, reacting with a gram of matter, would create an explosion rivaling a nuclear bomb. This leads to a great cosmic mystery. When the universe began, in the heat of the Big Bang, there should have been equal amounts of matter and antimatter. They should have been created in perfect balance. But if that were true, they would have instantly annihilated each other. The universe would have been nothing but a flash of light, leaving behind an empty void. But that didn't happen. We are here. The stars are here. Something happened in those first fractions of a second. A tiny imbalance occurred. For every billion particles of antimatter, there was 1,000,001,001 particles of matter. The billion pairs killed each other, leaving behind a sea of light. But that one single survivor, that one leftover particle out of a billion, is what makes up all the galaxies we see today. You are the remnant. You are made of the leftover dust of a great cosmic war that happened before time really began. We are the survivors of the annihilation. We live in a universe made of matter, looking out into the dark, wondering where our mirror twins have gone. Let us drift from the nature of matter to the nature of time. Time feels very real to us. It moves forward. You remember the past, but you do not remember the future. A glass falls and shatters, but shards never jump back up to form a glass. This is the arrow of time. But down in the quantum basement, time does not work like this. If you zoom in on a single atom or two particles colliding, the laws of physics work exactly the same way forward and backward. If you filmed a movie of two electrons bouncing off each other and played it in reverse, it would look perfectly natural. At the fundamental level, the universe does not distinguish between past and future. There is no arrow, there is only now. So, where does time come from? Why do we age? Why does the coffee get cold? It comes from entropy. Entropy is a measure of disorder. Imagine a library where all the books are sorted alphabetically. That is low entropy, order. Now imagine a library where the books are thrown in a pile on the floor. That is high entropy, disorder. There are only a few ways to have a tidy library, but there are millions of ways to have a messy one. The universe is constantly moving from order to disorder, simply because there are more ways to be messy than to be tidy. Time is not a force. Time is just the statistical probability of things getting mixed up. You, however, are a miracle of resistance. A living body is a temporary island of order in a universe that wants to be chaotic. Your cells are constantly working, burning energy to repair themselves, to keep the books in the library sorted. To be alive is to fight the flow of entropy. To be alive is to swim upstream against the river of time. But eventually, the river wins. This brings us to the ultimate end of all things and the strangest objects in the sky: black holes. A black hole is the place where quantum mechanics and gravity crash into each other. It is a star that has collapsed under its own weight, scrunching down smaller and smaller until it punches a hole in the fabric of reality. We used to think black holes were simple. They were monsters that ate everything and let nothing escape, not even light. We thought they were eternal tombs. But then Stephen Hawking applied quantum theory to the edge of the black hole, the event horizon. Remember the virtual particles we talked about? The pairs that pop out of the vacuum and destroy each other? Hawking realized that if a pair pops into existence right on the edge of the cliff, something amazing happens. One particle falls into the black hole, doomed, but the other particle is just outside the edge. It escapes. It flies away into the universe. To a distant observer, it looks like the black hole is emitting particles. It looks like it is glowing. This is Hawking radiation. It tells us that black holes are not truly black. They shimmer with a faint quantum heat. And because the escaping particle carries away a tiny bit of energy, the black hole pays a price. It loses mass. Over unimaginable timescales, trillions upon trillions of years, black holes evaporate. They shrink slower than a snail, fading away into the dark, until finally they disappear in a last pop of gamma rays. This leads to a deep, unsettling question. What happens to the things the black hole ate? If you throw a diary into a fire, the book is destroyed, but the information is not lost. It is theoretically possible to collect all the ash, all the smoke, and all the photons and reconstruct the text. The information is scrambled, but it is still in the universe.
But if a black hole evaporates and disappears completely, what happens to the diary you threw inside? Did the information vanish from the universe? Quantum mechanics says information is indestructible. It can never be deleted. But relativity says the black hole destroys everything. This is the information paradox. To solve it, physicists have proposed one of the most beautiful and strange ideas of all, the holographic principle. Imagine a soda can. The can is 3D, it has volume, but the label is 2D, it is just a surface. The holographic principle suggests that when an object falls into a black hole, the information about it, its shape, its mass, its story, is plastered onto the surface of the event horizon, like a sticker on the can. The object is gone, but its data is preserved on the shell. And some physicists take this a step further. They suggest that our entire universe might be like that black hole. Look at the room around you. It looks deep. It has height, width, and depth. But it is mathematically possible that this is an illusion. It is possible that the entire universe is actually a two-dimensional surface, a cosmic screen at the edge of infinity, and we are just the projection. We are the hologram. The light and matter we experience are just the shadows cast by a code written on the horizon of the universe. You feel solid, but you might be made of information. You might be a song written on the walls of the cosmos, projected inward to dance in the light. Let this idea relax you. If you are information, you are indestructible. The form changes. The atoms disperse, but the data that makes you is woven into the fabric of space-time itself. As we drift past the black holes, we look toward the very end. We know the universe is expanding. The space between the galaxies is stretching. The stars are moving away from us. Eventually, billions of years from now, the sky will be empty. The stars will run out of fuel and fade like dying embers. The black holes will evaporate. The universe will enter an era called the Dark Era. It sounds sad, but in the language of physics, it is a state of perfect equilibrium. It is called the heat death. Everything will be the same temperature. No energy will flow. No time will pass because nothing will change. It will be the ultimate sleep. The universe began in a violent, hot explosion, but it will end in a soft, cool, eternal sigh. It is a return to peace. It is a return to the silence from which we came. But that is a long way off, trillions of years. For now, we are in the stelliferous era, the age of stars. We are in the brief, bright party of the universe. We are lucky. We are awake during the only time when life is possible. We're the universe's way of experiencing its own glory before it goes back to sleep. So, as you lie here in the dark, remember that you are not small. You are a giant. You contain more atoms than there are stars in the sky. You are made of the dust of ancient suns. You are kept solid by fields of invisible force. You are glowing with infrared light. You are a wave of probability stretching to the moon. You are a mystery to yourself. And as your breathing slows down, as your thoughts begin to unravel and lose their shape, you are simply obeying the laws of quantum mechanics. You are moving from a state of focused observation to a state of drift. You are becoming a wave again. In the waking world, you have to be one thing. You have to be a name, a job, a person. But in sleep, you can be everything. In sleep, you return to the superposition. You float in the ocean of possibilities. Let the gravity of the bed hold you. Let the Higgs field give you weight. Let the thermal vibrations of the air warm you. There is nothing else you need to do. The universe has been running perfectly for 13.8 billion years without your help. It will handle the night. It will spin the Earth. It will fuse the hydrogen in the sun. It will keep the electrons moving. You can let go. We have spoken of the light, and we have spoken of the atoms that you can touch. But there is a deeper silence in the universe, a vast ocean of things that are hidden from our sight. As you drift deeper into relaxation, let us explore the parts of reality that are invisible yet omnipresent. We know that the stars and the galaxies spin. They rotate like great cosmic wheels. But when astronomers looked closely at how fast they were spinning, they found something wrong. The stars on the outer edges of the galaxies were moving too fast. By all the laws of gravity, they should have been flung out into the darkness, like water flying off a spinning tire. But they stayed. Something was holding them. Something huge and invisible was gripping the galaxy, providing the extra gravity needed to keep the stars in line. We call this dark matter. It is a spooky name for a spooky substance. It is not dark like a shadow. Shadows are caused by blocked light. Dark matter is transparent. It is completely invisible. It does not reflect light, it does not absorb light, and it does not emit light. It passes right through walls, right through the earth, and right through you, as if normal matter wasn't even there. And yet, it is the dominant stuff of the universe. For every kilogram of normal matter, the stuff of stars, planets, and your body, there are 5 kilograms of this invisible ghost matter. The universe we see is just the foam on top of a deep, dark ocean. We are living in a rare, luminous minority. Imagine that your room is filled with this silent substance. It flows through the building. It clusters around the galaxy like a giant invisible cocoon, cradling the Milky Way in its gravity. Without it, our sun would drift away into the void. We are being held by a ghost. But there are other ghosts, too. Smaller ones. Travelers. Let's talk about the neutrino. Deep in the core of the sun, where the nuclear fire burns, neutrinos are born in unimaginable numbers. They are tiny subatomic particles, even smaller than electrons. But unlike electrons, they have almost no mass and no electric charge. They do not feel the electromagnetic force. Because they have no charge, they do not interact with normal matter. To a neutrino, a wall is not solid. A mountain is not solid. The entire planet Earth is just a wispy fog. Right now, at this very second, there are about 100 trillion neutrinos passing through your body. 100 trillion. Every second. They are raining down from the sun, piercing the roof of your house, passing through your skin, your bones, your bed, and continuing straight down through the crust of the earth, through the magma, through the iron core, and out the other side into space, without slowing down. You are transparent to them. You are like a ghost to them. They are the most solitary things in existence. A neutrino can travel through a block of solid lead that is 1 light year thick, 9 trillion kilometers of lead, and still not hit a single atom. They are the silent witnesses of the universe, carrying information from the hearts of stars and the edges of black holes. but never stopping to tell the story. There are vast detectors buried deep under the ice of Antarctica, listening for them. The ice is clear and still. The detectors wait for that 1 in a trillion moment when a neutrino actually crashes into an atom of ice, creating a tiny flash of blue light. In the deep, cold silence of the South Pole, we are catching the whispers of the sun. Now, let us shrink down again, past the neutrinos, past the electrons. Let us go inside the solid heart of the atom, the nucleus. We used to think the proton was a simple ball, a hard seed in the center. But when we smashed protons together to see what was inside, we found a chaotic, beautiful zoo. Protons are made of smaller things called quarks. The physicists who named them must have been poets. They gave the quarks whimsical names. There are up quarks and down quarks. There are strange quarks and charm quarks. And the heaviest, most elusive ones are named truth, or top, and beauty, or bottom. Your body is mostly made of up and down quarks. But for a fraction of a second, in high-energy reactions, the strange and beautiful quarks appear. These quarks are never alone. This is the rule of confinement. You can never find a single quark floating by itself. They are always holding hands, usually in groups of 3. They are bound together by particles called gluons. The gluon is the carrier of the strong nuclear force. It is the strongest force in nature. It is the glue that holds the nucleus together. Without it, the protons, which are all positive and hate each other, would fly apart and every atom in the universe would explode. But here is the strange thing about the inside of a proton. It is not a static bag of 3 marbles. It is a stormy sea. Inside the proton, quarks are constantly buzzing around near the speed of light. Gluons are popping into existence, creating connections and vanishing. Pairs of quark and antiquark appear from the vacuum and annihilate each other in a fraction of a second. The mass of the proton, and therefore the mass of your body, does not actually come from the weight of the quarks themselves. The quarks are tiny and light. 99% of your mass comes from the energy of the dance inside the proton. It comes from the chaotic motion of the gluons and the virtual particles. Think about that. You feel heavy because of the frantic energy trapped inside your atoms. You are made of trapped light and motion. The stillness of the stone or the calmness of your hand is an illusion created by a storm of activity so fast that it blurs into solidity. And what holds this storm in check? Balance. The universe is a master of equilibrium. Let us consider the vacuum catastrophe. This sounds frightening, but it is simply a puzzle. We talked about the virtual particles boiling in empty space. Physicists have tried to calculate how much energy should be in the vacuum. When they do the math using quantum theory, they get a number that is huge, infinite almost. But when we look at the universe, the vacuum seems calm. The expansion of the universe is accelerating, driven by dark energy, but it is gentle. There is a discrepancy. The math says the vacuum should be explosive, but reality is calm. It is the biggest mismatch in the history of science. It tells us that there is something fundamental we still do not understand, a secret layer of the rug we haven't pulled back yet. Some believe this points to supersymmetry, the idea that for every fermion, matter particle, there is a boson, force particle, that cancels out its energy, calming the vacuum down. It suggests that the universe is built on a perfect hidden harmony, a mathematical mirror that keeps the chaos of the quantum foam from tearing the world apart. Even though we don't fully understand it, it works. The vacuum is stable. The proton is stable. You are stable. Drift on that thought. Stability. Despite all the chaos, despite the virtual particles popping in and out, despite the ghostly neutrinos and the invisible dark matter, the world holds its shape. The laws of physics are not just rules, they are a cradle. They rock the universe into a steady rhythm. Consider the temperature. We talked about the heat death, the absolute cold, but there is also absolute hot. The Planck temperature. It is the highest temperature possible. Beyond it, physics breaks down. And there is the Planck length, the smallest possible distance. The universe has pixels. It has a resolution limit. You cannot cut space into infinitely small pieces. Eventually, you hit the bottom. You hit the grain of the canvas. This suggests that the universe is finite in its complexity. It is not an endless abyss of detail. It is a constructed thing, and like a well-made bed, it is designed to support you. As we move through this invisible zoo, imagine the colors. We see light in a tiny spectrum, red to violet. But the universe is full of colors we cannot see. There are radio waves, huge and slow, passing through your room carrying songs and voices from distant towers. There are microwaves vibrating the water molecules. There is infrared, the light of heat glowing from your own body. If you could see in infrared, you would look like a luminous being of golden light against the cool darkness of the room. There are X-rays and gamma rays, sharp and bright, born in the depths of stars. You are bathed in invisible light. You are swimming in a sea of frequencies. The silence of the room is actually a symphony of electromagnetic waves, bouncing off the walls, passing through the window. But your eyes are closed. You don't need to see them. You can just feel the hum of existence. It is all information. The radio waves carry news. The light carries images. The neutrinos carry data from the sun. The gravitational waves, ripples in the fabric of space itself, carry the story of colliding black holes from 1 billion years ago. The universe is whispering its story in every direction all the time. But tonight, you don't need to listen to the whole story. You can just listen to the quiet. You are part of the signal. Your brainwaves, slowing down now into the alpha and theta rhythms of sleep, are also electromagnetic pulses. You are broadcasting a signal of peace into the room. We have explored the dead vacuum and the burning stars, but there is another place where the quantum world comes alive. It is here, in the biosphere. For a long time, scientists thought that living things were too warm, too wet, and too messy to maintain delicate quantum states. They thought the noise of life would drown out the subtle music of the subatomic, but nature, as always, is smarter than we imagined. It turns out that life itself is a quantum phenomenon. Consider the leaf. Imagine a green leaf fluttering in the wind outside your window. It is performing a miracle called photosynthesis. It takes sunlight and turns it into food. But how? When a photon of light hits the leaf, it excites an electron. This electron needs to find its way to a reaction center, a specific spot where its energy can be stored. It is like a maze. In a classical world, the electron would have to bounce around randomly, trying one path, hitting a dead end, turning back, trying another, until it finally found the exit. This would be slow and inefficient. Energy would be lost as heat. But plants don't waste energy. Experiments show that the electron doesn't just try one path, it uses quantum coherence. Like the wave passing through the two slits, the electron turns into a wave of probability. It explores every single possible path through the maze at the exact same time. It flows through the leaf like a ghost, instantly finding the shortest, most efficient route to the reaction center. Every plant on Earth is a quantum computer. Every blade of grass is performing a calculation far more advanced than our best machines, just to capture a ray of sunlight. The oxygen you are breathing right now was created by this quantum magic. The energy in the food you eat is sunlight trapped by a quantum trick. And it is not just plants. Look at the birds. Every winter, the European robin migrates thousands of miles south. It flies over oceans and deserts, navigating with perfect precision. It knows where north and south are, even when the stars are hidden by clouds. How? Inside the robin's eye, there is a protein called cryptochrome. When blue light hits this protein, it creates a pair of entangled electrons. We talked about entanglement, the spooky connection across distance. In the bird's eye, these two electrons are poised in a delicate balance. They are sensitive to the tiniest magnetic pole. As the bird flies through the Earth's magnetic field, the pull is just enough to tilt the balance of these entangled electrons. This sends a chemical signal to the bird's brain. It means that the bird can literally see the magnetic field of the Earth. It sees the magnetic lines as a visual pattern, perhaps a shading of light and dark superimposed over its vision. It navigates by following the quantum shimmer of the planet. And you? You might be doing it too. Think about your sense of smell. How do you tell the difference between the scent of a rose and the scent of an orange? The old theory was that smell works like a lock and key. The scent molecule is the key, and it fits into a receptor in your nose that is shaped like the lock. Shape matches shape. But there is a problem. Some molecules have completely different shapes but smell exactly the same. And some molecules have the exact same shape but smell completely different. A newer, stranger theory suggests that your nose is not just feeling the shape of the molecule, it is listening to it. The bonds between atoms in a molecule vibrate. They hum at a specific frequency. The theory of quantum smell suggests that when a scent molecule enters your nose, an electron in your receptor tunnels across the molecule, using it like a bridge. But it can only tunnel if the molecule is vibrating at the exact right frequency. Your nose might be a spectroscope, a device that analyzes the vibrations of quantum bonds. When you smell coffee in the morning or the fresh rain at night, you are detecting the quantum song of the molecules. You are sensing the vibration of matter itself. And deeper still, inside your cells, the work continues. Your body is a chemical factory. Reactions that should take years happen in milliseconds. This is thanks to enzymes. Enzymes are biological catalysts that speed things up. But for a long time, we couldn't explain how they worked so fast. They were thousands of times faster than they should be. The answer, again, is tunneling. Inside your enzymes, protons, hydrogen nuclei, are vanishing from one position and reappearing in another, skipping over the energy barriers that should stop them. Your metabolism, your digestion, the copying of your DNA, all of it relies on particles teleporting to get the job done. If quantum mechanics stopped working for a single second, your biochemistry would freeze. You would stop. Life is a rare state where the quantum world bubbles up to the surface and sustains the macro world. You are a quantum machine. Now, let us zoom out from the biology back to the stage itself. We have talked about the actors, the the particles, the forces, the life forms. But what about the floorboards? What about space itself? We usually think of space as nothing, a container. But Einstein taught us that space is a fabric. It can bend, it can twist. Imagine a trampoline. If you put a bowling ball in the middle, the fabric curves down. If you roll a marble past it, the marble curves around the bowling ball. This is gravity. Gravity is not a force that pulls you. It is the curvature of space that you slide into. The Earth is rolling around the curved dent made by the sun. You are stuck to the floor because the Earth has warped the space around it, and you are sliding down that slope toward the center. But this fabric is not stiff. It ripples. When two black holes crash into each other deep in the universe, they slam the fabric of space-time so hard that waves roll out in all directions. These are gravitational waves. They are ripples in reality itself. When a gravitational wave passes through you, it literally stretches and squeezes you. For a tiny fraction of a second, you become taller and thinner, then shorter and wider. Space itself distorts, changing the distance between your atoms. These waves are passing through us all the time. The universe is constantly shaking, ringing like a bell struck by cataclysms. But the ripples are so small, smaller than a fraction of a proton, that we never feel them. We float on a choppy sea, but we are too big to notice the waves. And what is this fabric made of? Is it smooth? Some theories suggest that if we looked closely enough, we would see that space and time are pixelated. This is the concept of loop quantum gravity. It says that space is not continuous. It is made of tiny interlocking loops, a chainmail of reality. You cannot move half a loop. You have to jump from one loop to the next. This means that motion is an illusion. Just as a movie is a series of still pictures played fast, your movement through the room is a series of tiny, discrete jumps from one quantum of space to another. You are teleporting through the universe, frame by frame, pixel by pixel. And what if space is a fluid? There is a theory that the vacuum of space acts like a superfluid. A superfluid is a strange state of matter that has zero friction. If you stir a cup of superfluid tea, it will keep swirling forever. It never stops. If space is a superfluid, then light is just a sound wave traveling through this liquid. The stars and planets are just vortices, little whirlpools in the ocean of the vacuum. We are swimming in a frictionless, eternal sea that we cannot see, because we are made of the waves within it. This idea connects us back to the ancients who believed in the ether. They were wrong about the details, but maybe they were right about the feeling that we are immersed in something, that we are not separated by emptiness, but connected by a medium. Let that feeling of connection deepen. The space between you and the walls is not empty. It is a fabric, a liquid, a foam. It connects you to the window, to the sky, to the moon. There are no gaps. The universe is a single, continuous blanket, and you are woven into it. As you lie there, feel the support of that fabric. Gravity is just the shape of the blanket holding you. It is a gentle curve, cradling you against the earth. It is the most natural embrace in the cosmos. You are exactly where you are supposed to be. You are sitting in the curve of gravity, breathing the oxygen of quantum photosynthesis, listening with the vibrations of your ears, conscious through the firing of neurons that rely on tunneling. You are a masterpiece of complexity, resting in the dark. And even your thoughts are part of this. Some scientists, like Roger Penrose, have suggested that consciousness itself originates in tiny tubes inside your brain cells called microtubes. They believe that the brain is more than a computer. They believe it is a quantum antenna. If this is true, then your dreams are not just chemical sparks. They are ripples in the fine structure of the universe. When you dream, you are playing in the quantum foam, free from the rigid rules of the daylight world. So, as we prepare to drift further toward the edge of understanding, remember that the mystery is not something to be solved. It is something to be experienced. You are the mystery. As we continue to float in this ocean of frequencies, we must ask a question that has kept astronomers awake for decades, but which will help you sleep tonight. Why is the universe so perfect? Imagine a giant control board, a mixing desk for reality stretching out in the dark. On this board, there are dozens of dials and sliders. One dial controls the strength of gravity. Another controls the charge of the electron. Another controls the weight of the proton. Another controls the speed of light. When the universe began, these dials were set to specific numbers. And here is the mystery. They are set to the exact, precise, razor-thin values needed for life to exist. If the dial for gravity had been turned up just a tiny bit higher, the universe would have collapsed back into a ball of fire millions of years ago. No stars, no planets, just a crushed crunch. If the dial had been turned down just a tiny fraction, the matter would have flown apart so fast that no stars could ever form. The universe would be a cold, thin mist of hydrogen forever. If the electromagnetic force were slightly different, atoms could not hold together. The electrons would fly away or crash into the nucleus. Chemistry would be impossible. Water would not exist. You would not exist. It is as if the universe knew we were coming. It is as if someone or something fine-tuned the machine to create a warm, stable pocket where life could bloom. This is called the Goldilocks enigma. Everything is just right. Some call this the anthropic principle. It says that the universe must be the way it is because if it were any different, we wouldn't be here to notice it. We are like a mold that fits perfectly into the shape of the container. The container was made for us. Or perhaps there are billions of other universes, bubbles floating in a fast foam of the multiverse, where the dials were set randomly. In those universes, gravity was too strong, or light was too slow, and they are dark, dead, and empty. We are simply the winners of a cosmic lottery. We are in the one lucky bubble that worked. Let this feeling of luck wash over you. Out of infinite chaos, you were born into a cosmos that works. You are in the safe zone. The laws of physics are holding you together with the precision of a master watchmaker. But what is this watch made of? We have talked about particles and waves, but deeper than that, physics suggests that the universe is made of math. If you strip away the skin of the world, you find equations. An electron is not really a thing. It is a set of numbers. It has a mass number, a charge number, a spin number. If you change the numbers, you change the particle. This leads to a strange and modern bedtime story, the simulation hypothesis. Look at a video game. On the screen, there are trees, water, and people. But if you zoom in, you see pixels. And if you look behind the screen, you see code, zeros and ones. Our universe has pixels too. We called them the Planck length. We cannot divide space smaller than that. It is the resolution limit of our reality. And we have a speed limit, the speed of light. No information can travel faster. Just like a computer processor has a clock speed, our universe has a max speed. Could it be that we are living in a simulation, that this entire reality, the bed, the room, the stars, is a program running on a computer the size of a galaxy. It sounds scary, but think of it this way. If we are a simulation, then we are safe. We are information. And in a good program, data is preserved. It means there is an architect. It means there is a purpose. It means that the reality you see is just the user interface, a simplified, user-friendly version of the truth designed to let you experience life. Maybe sleep is just a low-power mode, a defragmentation of the drive. When you close your eyes, the rendering engine pauses the world outside your room to save energy, waiting for you to wake up and look at it again. You are the protagonist of the code, and this code has a rhythm. It is not static, it breathes. We know the universe started with a big bang, an explosion outward. It is still expanding. This is the exhale. The universe is breathing out, growing larger and cooler, scattering the galaxies like dust in the wind. But what happens next? Some theories suggest the big crunch. Eventually, gravity might win. The expansion will slow down, stop, and reverse. The galaxies will be pulled back together. The universe will shrink, getting warmer and tighter, until everything returns to that single, tiny point of unity. The inhale. And then, the big bounce. The point explodes again, a new Big Bang, a new universe, a new roll of the dice, a new set of dials. Perhaps this has happened forever. Exhale, billions of years of stars and life. Inhale, billions of years of gathering and rest. Imagine the universe as a great pair of lungs, expanding, contracting, expanding, contracting. Try to match your breath to this idea. Inhale slowly. Imagine the galaxies rushing together, finding unity, returning to the source. Exhale slowly. Imagine the stars flying outward, creating space, creating light, creating you. You are a tiny mirror of that cosmic cycle. Your chest rises and falls just like the fabric of space-time. You are keeping time with the heartbeat of the universe. And in this cycle, nothing is ever truly lost. The atoms that make you up were once in the singularity, touching every other atom. And one day, they may return there, to touch again. We are all on a long, slow journey of separation and return. Let us consider the idea of the holographic brain one last time. If the universe is a hologram and your brain is a quantum computer, then perhaps your consciousness is not trapped inside your head. Radio waves are not trapped inside the radio. The radio just catches them. The music comes from the tower. Maybe you are the music. Maybe your brain is just the receiver catching a signal of consciousness that permeates the entire field of the universe. When you sleep, you are not turning off. You are just untuning the radio. You are letting the signal drift back into the static, back into the great universal hum. This is why sleep feels like home. You are returning to the default state. You are dipping your cup back into the ocean. Think of the silence of the moon. It hangs there, gray and still. No wind, no sound. It has been watching the Earth for 4 billion years. It is a monument to patience. Think of the silence of the deep ocean, miles down where the water is crushing and dark. Ancient creatures move slowly, bioluminescent lights flickering like stars. They do not know about the sun. They do not know about the cities. They only know the slow, cold drift. You are connected to all these silences. The silence in your room is the same silence. It is continuous. If you could open the door and fly upward, past the clouds, past the atmosphere, you would slip seamlessly into the quiet of the cosmos. There is no barrier. The peace in your mind is part of the peace of the vacuum. We have listed so many facts tonight. We have talked of quarks and quasars, of tunnels and time, but the most important fact, the 101st fact, is this. You are not in the universe, you are the universe. You are not a stranger walking through a strange land, you are the land. You are the eyes of the cosmos looking at itself. You are the way the universe understands its own beauty. The carbon in your eyes, the calcium in your jaw, the iron in your blood, it is the same stuff that makes the mountains and the meteors. There is no you and it. There is only us. One vast, energy-filled, vibrating, breathing thing. And right now, the universe wants to rest. It has worked hard to create this moment. It spent billions of years fusing atoms, cooling gas, evolving cells, just so you could lie here warm and safe and close your eyes. The show is over for the day. The experiments are paused. The observer is taking a break. So now, let the physics fade. Let the equations dissolve into the dark. We have traveled from the center of the atom to the edge of the galaxy, but the journey is done. The telescope is turning off. The observatory is closing its dome. It is time to bring all that vastness back home, back into the small, warm space of your body. Visualize the atoms in your arms and legs. For billions of years, they have been dancing. They have traveled through stars and space to be here. But now, they are tired. Imagine them slowing down. The frantic buzzing of the electrons is quieting into a soft, steady hum. The storm inside the protons is settling into a calm sea. You are a galaxy of particles, and you are ordering them to rest. Feel the bed beneath you. Remember, it is the electromagnetic force that holds you up, a gentle force field of resistance. Trust it. You don't need to hold your muscles tight. The field will not let you fall. The earth will not let you go. Gravity is cradling you, pulling you down into the mattress, anchoring you to the planet so you can sleep while the world spins. Let your breathing become the tide. Inhale, the universe expands. Exhale, releasing the entropy. Inhale, drawing in the stardust. Exhale, releasing the entropy. Everything is slowing down. The light in the room is just a memory. The sounds outside are just waves that wash over you without touching you. You are becoming transparent. You are becoming a neutrino, passing through the night without friction, without worry. Let us count down now. We will count backward from 10 to 1. With each number, we will turn off a different force of nature. We will dim the lights of the cosmos. We will step closer to the 0 point. 10. Feel the gravity heavy on your eyelids. The curvature of space is gentle but firm. It is pulling your eyes closed. It is pulling your shoulders down. The weight of the stars is a blanket covering you. 9. The electromagnetic force relaxes. The tension in your jaw, the tension in your hands, it is just energy, and you are letting it dissipate. The bonds between your muscles soften. You are melting into the field. 8. The thoughts in your mind are losing their shape. They were particles, sharp, distinct, noisy. Now they are becoming waves. They are spreading out, rippling away into the distance. No more focus, just a smooth, wide ocean of probability. 7. The arrow of time slows down. The past is gone, the future is not here. There is only this frozen block of now, a single eternal moment of comfort. You are stuck in the perfect present. 6. The light fades. The photons are stopping. The screen of the universe is dimming. The colors are turning to gray, and the gray is turning to a soft, velvety black. The simulation is entering sleep mode. 5. You are entering the tunnel. Like the electron passing through the wall, you are slipping through the barrier between waking and sleeping. You are tunneling into the dream world. It is effortless. You just drift through. 4. The connection remains. Even as you drift away, you are entangled with the safety of this room. You are entangled with the peace of the night. You are connected to everything, so you don't need to worry about anything. You are held by the web. 3. Entropy stops. The chaos of the day is organized into silence. The library is quiet. The books are closed. The noise of the world has been filtered out, leaving only the signal of your own slow heartbeat. 2. You are the vacuum. You are the empty space between the stars. Vast, silent, infinite. Dark energy is expanding within you, creating space for rest. 1. The singularity. You are back to the source. There is nothing left to measure. There is nothing left to observe. The wave function has collapsed into sleep. You are safe. You are stardust. You are the universe dreaming. Good night.